In the previous video, we discovered that the 2x2 distribution of four molecules between two halves of a box represents a state with the maximum statistical weight and maximum entropy. Ludwig Boltzmann was the first to link statistical weight and entropy, writing his famous formula. Entropy is proportional to the logarithm of the statistical weight of the system's macro state. This formula was a groundbreaking discovery, as it was the first to connect a macroscopic parameter, entropy, with the microscopic properties of a system, specifically the number of permutations of its particles within a given macro state. Boltzmann built a bridge between the macroscopic laws of nature and the realm of elementary particles, providing a new understanding of thermodynamics and physics as a whole. Boltzmann's formula interprets the tendency of entropy to increase, as stated in the second law of thermodynamics, as the system's movement toward its most probable state, the one with the greatest number of particle permutations, and thus toward greater disorder and randomness. This is why what we painstakingly organize with our hands, reducing entropy, falls apart on its own. Entropy consumes everything, even people. Of course, this applies only to isolated systems. The thermodynamics of open systems is more complex, allowing for the spontaneous formation of ordered structures from Bénard cells to stars and biological organisms. Surprisingly, Ludwig Boltzmann faced significant criticism and misunderstanding from the scientific community during his lifetime. His work in statistical mechanics and thermodynamics, particularly his famous formula, sparked heated debates. At that time, many scientists, even brilliant ones, especially proponents of classical mechanics, rejected or failed to understand his ideas about the probabilistic nature of thermodynamic processes. One of his opponents was Ernst Mach, an influential scientist and philosopher who criticized Boltzmann's work and the very concepts of atoms and molecules, considering them unverifiable abstractions. As a result, the scientific community was slow to accept Boltzmann's ideas. This led to isolation, severe depression, and ultimately the tragic death of the scientist. Recognition of his work came only after his death, when experimental data and studies by other scientists confirmed the validity of his theories. Boltzmann's formula was engraved on his tombstone as a symbol of his contribution to science, which was appreciated only years later. In 1964, the International Astronomical Union named a crater on the visible side of the moon after Boltzmann.